Welcome back, and in this video I'd like to talk to you about the color of light, or the light temperature, and how it relates to your white balance. But before we getting into the technicality, I really would like to talk to you about a practical example, and I'm sure that all of you have had this issue. Imagine that you've been asked to take the pictures of a wedding. So early in the morning, you're going out and you're taking the pictures of the bride while she's dressing up. A little bit later, you're taking the pictures at the city hall, and later again during the dinner, and then late at night, the romantic part. So you've taken all these pictures and you're so happy about it and fulfilled and tired. You're going home and you hit the sack, and the next morning, the first thing you do, because you're all excited, you turn on your workstation and you're looking at your pictures. I mean, they're absolutely stunning. Really nice. However, there is one problem. You remember that the bride had a snow white dress on, and she actually spent a lot of time in finding the right dress. And now in my pictures, my dress looks a bit yellowish in the morning, a bit green during the lunchtime, and during the dinner it's kind of blue, and late in the evening in the romantic part it's kind of red. Now that's not good. I cannot give these pictures to this lady. I mean, she's gonna kill me, right? I mean, she wants to see a white dress. Well, that is the effect of light temperature. Now, in the late 1800s, there was a guy called William Kelvin, and he tossed a piece of carbon, and carbon is pitch black, into a fire, and he started to heat up this carbon, and he noticed while temperature was going up, the tint, the color of the carbon was shifting as well. So the carbon was cold, black, and then it became kind of red, orange, light orange, yellow, green, white, blue. So he mapped this out on a scale. Degrees of Kelvin, which is just a temperature measure, compared to a specific color at a specific temperature. So it just happened to be so that light sources, like a light bulb, have a certain light temperature. They emit light at a certain temperature. Now, a light bulb is around 2,800 degrees Kelvin, and it emits yellow light. A candle, on the other hand, like those there, they emit kind of reddish orange light, and the temperature is around 1,800 degrees Kelvin. You can find this back on the Kelvin scale. LED light is typically around 6,000, 7,000 degrees Kelvin, and is kind of bluish. And we all know the TL lights, the fluorescent tubes. They typically generate light around 3,800, 4,000 degrees Kelvin, and it's kind of green. So now that we know that different light sources have different light temperatures, we can explain why our pictures are reflecting the wrong color of the dress, especially that we've been shooting the whole day with the camera in a white balance mode of daylight. Now, remember now, when we were out there shooting early in the morning in the ladies' dressing room, we wanted to take pictures with ambient light. We didn't want to use the flash at all because we didn't want to spoil the atmosphere, and we want to be big on the background. And that room was lit with light bulbs. There were plenty of them all around, plenty of light. That light was emitting down onto the lady's dress, that was then reflected back into the camera, and we know this is kind of yellow now. So that's why the picture as such is now a yellow picture, because the camera registered like that. Later on the day, when we were in the city hall, we had a similar situation. We had the fluorescent lights on the ceiling emitting green light, shining down on the white dress again, but that was reflected back into the camera as green. During dinner, we had these nice LEDs hanging on the ceiling, putting nice light on everybody, but that reflected back on the white dress as kind of blue, because these emit kind of blue light, and as such the camera did register a kind of a bluish tint to the dress. And late in the evening, in the romantic part, when all the candles were on and the lady was sitting next to the candles, the dress really looks orange, because that light is a kind of orange light reflected back into the camera. So now we know why our camera has actually recorded these different colors. That's the temperature of light effect, and in combination with the white balance. Now, something is really funny though, because I was out there the whole day and I've never seen the dress with my own eyes being any other color than snow white. And that's because our brain is so intelligent, is so smart, that it does an automatic white balance adjustment. Our brain knows that snow is white, snow is not green, snow is not blue, snow is white. So it knows that, so it does that correction for us. Now a camera, on the other hand, is a pretty dumb device. A camera has a sensor in the back, be it a CMOS or a CCD, it doesn't really matter. It captures photons, and a sensor is built out of a matrix of all little receivers, pixels as we call them often. And when light falls through the lens, and light are photons, and those are small charged particles, when they hit the pixel, they will put a charge in the pixel. If you have a lot of light, a lot of charge. If you have a little bit of light, low charge. Now the charge of the pixel will then be calculated in the camera to a value between 0 and 255, to keep it simple. And we also know that 0 means no light and 255 is a lot of light. De facto, the CCD in a camera is black and white, and any gray shade in between. Now to make the camera be able to register color, they place in front of the CCD, they place what we call a Bayer filter. And a Bayer filter is a patchwork of red, green and blue. Well, we all know red, green and blue because these are our main colors that we use as photographers in our applications like Photoshop and Lightroom and Capture One and so on. So now the camera can capture colors, but it still needs to be calibrated. So the way they do this is very simple. They take a camera, they take a gray card, and they use a light source that actually lights the gray source, the gray card, and then it bounces back in the camera. But the light source that they use is a steady 5,100 degrees Kelvin source, very accurate. So when it hits the gray card, and we know that gray is equal amounts of red, green and blue, 18% gray card, it bounces back in the camera, the pixels are getting charged and they are read out. If the red, green and blue pixel are equal in value, then we normally have gray. But because it's a hardware component, it will differ a bit. But it doesn't matter, because we will tell the camera what you see now, the values that you read for your red, green and blue channels or pixels, whatever you read there, that means it's gray. So we're just telling the camera what you're seeing right now is gray. And now that's the reference for the camera. From now on, the camera will be able to calculate the colors properly. Now, if I now take the same gray card and I change my very solid, accurate light source to an ordinary light bulb, which is emitting at 2.8 kilo degrees of Fahrenheit, and it's yellow light, it will bounce back in the camera, and my RGB values on my camera will no longer be that equal. They will be way off. So my camera will say, oh, well, this is not gray. I mean, this is another color, and it calculates it, and it makes it a bit of kind of yellow, the picture. So that's what a camera does. Now, that on itself is a bit of an annoyance, because that would mean that with a camera you can only shoot with daylight temperatures, and any other light that is around would just offset your colors. That's why a lot of vendors have invented a dial with little icons on it, and I'm sure you've seen the little clouds and the little bulbs and the little suns and overcast symbols. and the flash symbol that you can select the white balance accordingly. So if you know what the light source is about, you know the temperature of that light, then you just select the right position on your white balance selector and you shoot, and your pictures will be pretty much all right. Now, people are pretty lazy, and me especially, and that's why they wanted to have an automatic white balance. And people that build cameras and design cameras, they went through a lot of effort to create an automatic white balance. They took thousands of pictures with different light sources, and once they've done that, they were able to create a mathematical formula called an algorithm with all the variables in it that allows the camera to correct the pictures, irregardless of what light sources are out there, what light temperature is out there. It's a piece of software which is embedded in your camera, part of the picture processing. It does a good job, but it doesn't always work. It's automatic and it's limited. So if you shoot a wedding and the wedding dress has to be the same under extreme circumstances, then you should not use the automatic white balance. There are other methods. Now, back to my pictures, right? How would I do that? I mean, my pictures are still there now and they're still not right. So what can I do? I cannot go back and shoot again and use my gray card and all that. The only thing I can do now, if I was shooting in RAW, is actually, to use my white balance sampler and pick on a gray object in the picture and say, okay, or a color neutral object in my picture saying this is kind of gray, and then I would adjust my white balance. So if I was to do it in this room, I would use this candelier to put my white balance sampler on in my application and tell them this is gray. Now, that will work, but only if you were working in RAW. If you were working in JPEG, you're screwed. You cannot adjust that. You can adjust it a little bit, but you cannot get it right anymore. So always shoot in RAW. Okay. Now, my background is engineering, and as an engineer, we always try to fix the problem at the source. You don't try to fix it afterwards. So, my approach of taking pictures is very simple. And let's go back to the early morning picture with the lady that is getting married, right? With the light bulbs in the room. So I would go over there, I would put my gray card on the stand, I would take my camera, and I would take a shot of it. My camera would probably be on daylight, and I would take a shot of that gray card, and then I would keep shooting the model again all day long, Now, when we move out to the city hall, I do the same thing again. I shoot my gray card, and then I shoot the people in the city hall. And I do this each time my light sources, my light temperature is changing. So, having said that, when I then come home, I offload my card and I stick it in my workstation, and I open up my Lightroom or my Capture One Pro or whatever you have, with a RAW processor, and I go to the first picture of a series that was taken with the same light temperature. I pick my gray card, I'll put my white balance sampler on it, and then I will see that my color temperature will change, and then I'll apply that value to all the sequential pictures that were taken in the same environment, the same condition. If I then go on to the next place, well, I mean, as I said, I took another picture again in the city hall, and I just need to sample again my gray card there and then apply that temperature to the remaining pictures. That's a pretty easy one to do, but you still have some work afterwards. There's another method whereby you can just go out and be with the lady in that dressing room again and have your gray card, but now you position your camera on pre-white balance. Now, pre-white balance is a simple thing. You're going to tell your camera what you see now is gray, right? Camera, that's gray. So no matter what the light sources are, so you hold up your gray card and you shoot, but make sure you only have the gray part of the card. So then your camera knows this is gray, this is its reference. It's very similar to the calibration we've done before. And then you keep shooting. And in the next location, you do exactly the same. Then in the post-processing with pre-white balance, you don't have to adjust anything anymore on the white balance because it's already correct. So that's a bit about the white balance and the temperature of light. So to summarize, we can say that light sources are emitting light with a certain temperature. If you want to know what temperature a light source emits, look on the scale created by William Kelvin, and you'll see that you will find light bulbs and you will find halogen spots and all that. They are matching into a specific temperature, and then you can find out what color they are emitting. That's one thing. Secondly, is that the white balance on your camera is very important to have that right, and that a gray card is a very good tool to tell your camera or inform your camera what the light conditions are, what the light temperature is at that moment you're shooting. More specifically with pre-white balance, that's is an easy solution. If you don't want to do pre-white balance, you can still shoot a picture of your gray card in a certain circumstances, and then afterwards in post-processing you take your white balance picker and say, okay, this is gray. And that's about it for now. I hope you enjoyed it a bit, that it was not too technical. And in my next video, we'll be talking about how you can make the right pictures in terms of color and light color in an environment whereby you have light bulbs and you have LEDs and you have candlelight and you have daylight and you have flash all mixed together, on how you can actually overcome a lot of problems there. So thank you for watching, and I hope to see you again.